Welcome back, guys. Same topic. Um, the first derivative test. And while we know that if I'm given a function, I like take the derivative and I set it equal to 0 and I see what happens. But like in this one, this is a favorite way that they do this on the AP test is they say the derivative is given by this. And f of 1 is 7. I don't think we're going to need this. This is like for a second part of the problem, but they tell me the derivative for x greater than 0. So like I don't have to take the derivative, I'm just given the derivative. And it says the function f has a critical point at x equals 3, which you might be able to tell because if I plug a 3 in here for x, I get f prime is equal to 0 because 3 minus 3 is 0. It turns out for this function, that's the only critical point, but we don't have to worry about that. It just says it has a critical point at 3. At this point, does f have a relative min, a relative maximum, or neither? It says justify your answer. We'll talk about that in a minute. But we can start off by just using our little sign chart to help us out. It says the critical point is at x equals 3, so I put a 3 in here. And I'm going to plug a number in to the left of 3 and a number to the right of 3. To the left of 3, I'm going to choose 0 because that's usually pretty easy to plug in. Doesn't matter what you choose, but I'm going to choose 0. And to the right of 3, I'm going to pick 4 because it's 1 bigger than 3. So now I evaluate f prime of 0. Sorry, this is the f prime line. I do f prime at 0 and f prime at 4, and I'm going to fill in like little minuses or little pluses as is appropriate. So f prime of 0 is 0 minus 3 times e to the 0. E to the 0 is 1. So this is negative 3 times 1, which is negative 3. And that is negative, less than 0. So I put a bunch of negatives over here. Actually, I cheated. I can't do that. I'm going to start that over. It says for x greater than 0, so I can't use 0. I have to use a different number to the left of 3. And I mean, I don't know if that's going to make a difference, but I shouldn't be plugging in numbers that aren't in the domain of the function. I'm going to plug in 1 instead. So I get 1 minus 3 times e to the 1, which is negative 2e. And while I don't actually care the value of this number, I know that it's negative. So this is negative, which means I put a bunch of minuses here. So it turned out it didn't make any difference whether I chose 0 or 1, but it's good not to choose the wrong one. And then I got to plug in this number over here to the right of 3. So that's going to be f prime at 4. Now it's going to be 4 minus 3 times e to the 4. This is 4 minus 3 is a 1, so it's just e to the 4th. And while I maybe don't know what that is, I know it's positive because e is positive. And anytime you raise a positive number to a power, you get a bunch of positive numbers. So these are all pluses. Now I can look at this and I can say, well, this function goes from decreasing to 0 to increasing, or the derivative goes from negative to 0 to positive, which means at this point 3 is a minimum. 3 is a relative minimum. So I say x equals 3 is a relative minimum of, what's it called, f of x? Yeah, of f. Because, and now I want to, because is the justify your answer part. We said the answer, but now we got to justify it. And there's two ways to do this with what we know so far. One way is to say this. Because f decreases for x is less than 3, and f is increasing for x is greater than 3. Okay, which is almost exactly what this picture states, but the picture is not enough of a justification. You have to say why. So either because f is decreasing for x less than 3, and f is increasing for x greater than 3. It's like it decreases, and then and then it increases. That tells me that this is going to be a minimum value. The other way to say it, this is method 1. The other way is to say this: x equals 3 is a relative minimum of f because you can say f prime is negative for x is less than 3, and f prime is positive for x is greater than 3. I want to emphasize the point that f decreasing and f prime negative mean the same thing, which is why it's okay to say either one of these. F decreasing, f prime negative, these mean the same thing for f. Likewise, f increasing and the derivative being positive, f prime greater than 0, these mean the same thing too. That's why you can say this either way. What you can't say is like f prime is decreasing and f prime is increasing, because that's a different statement. And you can't say f is negative and f is positive, because that doesn't actually tell me that it's a minimum. So it's got to be one of these two statements. Either talk about the function increasing or decreasing, or talk about the derivative being positive or negative. But you can't do it any other way. So it's really pretty much, these are pretty much the only two ways to justify your answer. Show that f of x equals log x is always increasing. Ooh, okay. Always increasing. So I guess that means you take the derivative and show that it's always positive. Well, f prime of x would be 1 over x. And f prime of x, so like the question is like 1 over x greater than 0. I guess the better way to think about this is this. This is a fraction, and a fraction is positive when the numerator and denominator are either both positive or both negative. So f prime of x is greater than 0 if x is greater than 0. And the thing is, the top is always positive. So the bottom, so for the whole thing to be positive, the bottom also has to be positive. For a fraction, they're either both negative or both positive to get a positive fraction. But since the top can never be negative, it's just the number 1. The bottom also has to be positive. But I can say f prime of x is less than 0. Well, if the bottom is negative, then this is negative, right? If I say, well, what if I plug in -1 for x, right? Then the derivative is -1, so it's less than 0. So how is it that I show that it's always increasing if the derivative can be negative? And the answer is right here. Like, I don't have to worry about these because the domain of the natural log, domain of any logarithm, but the natural log in particular here, is all the x's that are greater than 0. You can't plug a negative number or a 0 in here because it just doesn't work. Like the domain, this thing is defined as only having a domain of x greater than 0. So I can ignore this part. So the only way to get a positive, the x's that I plug in here have to be positive, which means f prime is always positive. F prime of x, I'll just say greater than 0. For all x in the domain of f. Oop, I wrote of x, and that's wrong. All x in the domain of f. Cool. Find and analyze the critical points. All right, this is gonna be one where we like have to do a sign chart and stuff. So, oh boy, I just put the screen shade on. Not what I meant to do. So find and analyze the critical points. Got to find them first. So I find them by finding f prime, which is 3x squared minus 24x plus 21. And since this is a polynomial, it's always defined, so I don't have to worry about the f prime being undefined part of critical points. But I do have to set it equal to 0. So 3x squared minus 24x plus 21 equals 0. Here we divide everything by 3 to get rid of all those coefficients. X squared minus 8x plus 7 equals 0. Then this factors to x minus 1 and x minus 7, which gives me x equals 1 or 7. So there's 2 critical points, but the interval they gave me is from 0 to 2. Only one of my critical points falls into that interval, so I don't actually have to worry about what's happening. I don't have to worry about the 7. So I can do this, make myself a little sign chart so I can analyze. X equals 1. X equals 7 is out here somewhere, which I don't really care about, but this is an f prime thing, right? This is f prime still. F prime, yeah, F prime is this thing. So I'm going to plug in a number over here and a number over here. Well, I don't think it really matters because we know that the only critical points for this function anywhere is from 1 to 7. The fact that they're asking me from 0 to 2 means that I probably shouldn't choose x's that are outside of that interval. So it's like, I want an x in here and an x in there. And that's kind of annoying because they're going to be fractions, right? So like 1/2 and 3/2. Now you're like, well, I got to plug a half into this thing. That's annoying. But life is like that sometimes. We don't actually have to plug it in. We just have to figure out if it's positive or negative. So I'm going to plug it in. This thing is numerically equivalent to this thing, right? I don't have to worry about the 3. I can factor that out or something. So, so let's see. If I plug a 1/2 into here, I get 1/2 squared minus 8 times 1/2 plus 7. Well, 1/2 squared is 1/4. 8 times 1/2 is 4. So minus 4 plus 7. This is really negative 1/4 plus 3, which is going to be positive. I know that 3 is bigger than a 4, so this is going to be a plus. I'm going to plug in 3/2, which might be a little less obvious, but we'll see what happens. 3/2 squared minus 8 times 3/2 plus 7. 3/2 squared is 9/4. 8 times 3/2 is 12. So this is 9/4 minus 5. I know that 5 is bigger than 9/4. 9/4 is just a little bigger than 2 because 8/4 is equal to 2. So we're talking like something negative here. So it's going to be negatives. So I'm now done. I've discovered the critical point was 1. I did some analysis where I looked to the left and to the right of it. I see that the function is increasing 0. Sorry, the function is increasing constant 0. The derivative is positive 0, negative. It's going to be a maximum. So I could say something along the lines of x equals 1 is a maximum of f of x. I think that language is okay. Maybe I'll do like one more of these or something, and then we'll move on with our lives. But I don't want to do this one. This one's terrible. Yeah, I'll save at least. Yeah, I'll save these for school. I don't want this. I know these videos are getting kind of long, so I'm going to go ahead and chop it right here. We can talk about those in class before we do the classwork. Hope this helped. Bye.